All right. Not that anyone's missing, but this is what we're going to do for practice today. It is the 13th. We're doing the zero product property, and we've already done this. Right? Because I overteach you. So then there are days of like slow back down, and then days of press on the gas pedal, and then. Yeah, because it was preview, quote unquote, by CPM, but I was hoping it wouldn't really be preview. I was hoping you guys would know about it. So here's to that hope. Who can explain what we do with the zero product property and how it can take us from an equation to a graph? How can the zero product property take us from an equation to a graph? But, I mean, you can't. If I just give you a quadratic trinomial right now, you can just graph it?
I mean, you have to, like,
well, it'd probably be a little hard to do, but I might be able to.
How?
Wait, do we need...
Yeah, I pressed down on it and it went more than I expected. How do we graph it? We'll end up talking about that again.
Okay.
How we knew to graph those, that's a good segue actually. How we knew how to graph those derives from, well, yesterday you wouldn't have realized that it was zero product property, but then we built the trinomial from the information they gave us. So yesterday we were really operating going either this direction, one of the things we had a table, and actually we drew a graph based off the table, and then I think we derived an equation, maybe?
Yeah.
Another way to situation where we started with like the balloon started here, it ended there, and then we were able to model some things. We're not able to remember what zero product. It's okay if we're not. I'm just taking wait time.
I don't think something multiplied. AB equals 0, then A or B has to be 0. I might know it. I just don't remember.
That was on the homework.
Well, none of you all spoke up and said that.
I might know it, but I don't know that it was called the zero.
So, okay, different question. If we're going to go sketch a parabola, or really any graph, but especially a parabola, how many points is safe?
More
Are 3 points safe?
No, I feel like it'd be like the X intercept, the Y intercept, and the 5 sounds so like 4. 5 or more.
I would say 2 down.
I heard 9, I heard 5 or more, I heard 4. 4 even number. If we're going to use the vertex, we should probably have an odd number because the vertex will be, the one that sits out. So, okay, if I tell you that a parabola has a y-intercept of negative 15. And that's it.
Well, we're not.
Can you sketch it?
No.
Well, okay. Don't look at me like I'm silly. Some of you like...
Yes.
So, what about if I have the x-intercepts, like yesterday, right? We know where the balloon launches from, we know where the balloon lands. So, for example, if in a situation they gave us negative 3 and 5, there's your x-intercepts.
No. I feel like we need more. Because we don't know what the vertex is.
So what if I tell you those 3 things go together?
Then I feel like we could start.
Try that. Throw an XY axis on your paper. Put points on the x-axis at negative 3 and 5. Put a point on the y-axis at negative 15. You can scale if you want to. Is it enough? Or what else can we figure out? Would this graph be concave up or concave down?
It would go down.
So, like, put those points there, and then. So, does it look like a U or does it look like an A?
It looks like a U.
looks like a U, right? Because that negative 15, what we're going to end up with, if I just make a really vague graph in a way, negative 3, positive 5, negative 15 would be somewhere pretty far down here. We'll just say it's that. Is this the vertex?
No. Because it has to be the same distance between the two x's.
Okay, so we know then the vertex has to split this gap.
Yeah.
So actually at 1, right? Because if this is 5 and this is negative 3.
Yeah.
So then we know that the vertex point is going to exist at 1. Sorry, not that point. One something, right? Is there a way for us to know that?
We know that it's
No.
lower
Yeah, less
than
than.
Does the 0, negative 15, is that useful in any other way? So we've got negative 3, 0, right? 5, 0, 2 points. 0, negative 15, 3 points. The makings of a 4th point.
Didn't you do something yesterday? Like, I forget what it was called. And then you got like the equation out of like the 3 points. Not snowballs.
What's one aspect of parabolas that we all agree on?
They're symmetrical.
They're symmetrical.
So I mean, we have another point as well.
So we have another point as well?
Oh wait, so you could say that there's like the distance from 3 to the y end should be the same from y to like.
Now you're trying too hard.
No.
Okay.
No, you're right, but you're trying too hard. Do this distance.
Oh.
Don't do this.
Okay.
That's more just do this and reflect it. Right? So out here, oh come on, give me a pen. Out here there is 2 negative 15. Okay. Alright, we're on to something here. But we only have 4 points at this point. Can we use like this? Like we know it's going to curve. Is there any productive use of this? I mean, so we go up by 3, and we go up by 15, right? Yeah. The slope is 5, right? 15 over 3, rise over run. So the relative, I mean, we know it's not actually that, but if we drew a straight line, the slope would be 5. Let's make a table really quick. We know negative 3, 0. Don't know negative 2, don't know negative 1. We know 0, negative 15. 1 we don't know, but we know it's less than negative 15. 2 we know is negative 15. 5 is 0. So if this was linear, these would all be consistent, right?
Yeah.
But it's not linear.
If it was linear, it'd be like 0, negative 5, negative 10, negative 15.
Yeah, 0, negative 5, negative 10, negative 15. But it's not. just compared this to like the parent function of x squared. Like, so x squared here would be 9.
And then we could do like we did yesterday.
So x squared
like
minus 9.
Well,
I mean, that would work here.
but it wouldn't work for that.
It doesn't work here.
So we're trying to figure out.
Shoot. X squared minus 15? That would work here,
But not
but not up here.
so then
But wait, the bx here doesn't matter. Remember, so if we, hold on, let's start playing through this. By the way, side note, this is one of those, like, I'm going to act like I don't know what we're doing sort of
Oh,
things.
that's why you're acting so like okay.
So, if we tried, let's just start using function notation. If we start trying f of x, so y, right, the output, doesn't matter what we use, is x squared plus or minus something b, I'm going to leave that alone, minus, well, yeah, because the y-intercept is minus 15. Yeah, so that should be, no. Is it, so wait, minus 15 or minus 9? Which one do we want to try?
minus 15.
Here, if we did x squared minus 9, this is, that would give me
I'd
0.
do
Okay.
negative 15 because that's the y.
Yeah. Plus out the 9.
No, wait. I remember something.
Oh, you remember something?
These points,
Okay.
right, these are special to our parabola because it goes down and comes up. And these are our zeros, right? So the parabola is 0 when
X plus.
Oh.
right?
Yeah, so then you find out what x
Figure out what
is,
x
and then
is. So like what?
Well, no, we know what x is. X is either negative 3 or positive 5.
You're right because
When
one
it's
of them
0.
has to be 0.
But if we, instead of saying 0,
f of x.
just say f of x. What,
Because
can we do this?
yes.
Well, let's try it. Let's see if this works. What is, so if we FOIL through this one, we don't just do the first and the last. We got to FOIL. We got to do every part of it. So x times x is x squared. Outer negative 5x. Inner positive 3x. So negative 2x.
And then negative 15. So we have the x squared and the negative 15.
Now hold on. Let's check. Will this work? So if x is negative 3, negative 3 squared is 9, minus negative 6, so actually plus 6. Ooh, 9 plus 6, 15. Minus, ooh, that works.
And then
Wow,
we just
it's
go
working.
and then
0,
0.
0, negative 15. Okay. Wait, what about 2 to get negative 15? 2 squared is 4. Minus 4 is 0. This is working.
Wow.
It is cool. Because we had no clue how to derive this. We were just going to start like stabbing in the dark, like guess checking, like what works and what makes the map. Like,
If you're lucky enough, you might find something.
essentially, yeah. That's the if you've never heard that figure of speech, like stabbing in the dark is like there's an enemy in a dark room, and you're just like like you're not, there's no purpose. Like you should instead like sweep the room strategically or something like, like use a strategy. Don't just randomly.
What do you mean by strategically sweep the room with a knife?
This is what I mean. Strategically figure out what you can do. Now, problem is, this won't always work, but we know that this is the right function here, the right relationship, because did we only have the zeros?
No, we had others.
We had other points that we were able to check, right? If you only have the zeros,
Then it's
your function may or may not be correct with the other points, but hey, if you only have the zeros, then who's to tell you that you're wrong? But if we have the zeros and another point or two or whatever, then we can check our function.
so we have to have at least 30.
in our previous problem, we learned that if we know the intercept of a parabola, we can sketch its graph without necessarily making a table. That table we made was pointless.
Are you serious?
Well, it had a few points in it, but yeah, it was pointless.
It was pointless.
Oh my
Oh,
god.
like it had points, so it wasn't
Have
pointless.
them pointed out. Oh,
Hey.
I just made another one.
So, when we think about why we were able to use that, for all x-intercepts, these should be kind of easier problems to think through. What's the value of y? If it's an x-intercept. 0, right? So we know what. So if we know the intercept points, like the x values, we really know 2 points, right? Because we know the zeros. So if we look at a function like that, what's the y? Well, what do we know about the x on the y-intercept?
When x equals 0.
When x is 0, it's the y-intercept. So when we have a function such as that, we can figure out the y-intercept is. What's the y-intercept like in b? Yeah, you should be saying that with confidence. It's your constant. Negative 12. It's always the constant. Whether it's linear, whether it's linear or whether it's quadratic, your constant is the y-intercept because it's the thing that isn't impacted by x. Right? When x makes everything 0, it isn't impacted. So, what equation would we need to solve to determine the x-intercepts of that graph? We know the y-intercept, right? That's one point we can check with. So this is 0, negative. Go ahead and write down that trinomial, please. Whether you write y or f of x is up to you. Y? I like the choices.
Is f of x and y also the same as t of n?
Well, yeah, it depends on what you're calculating, but t will often use like time. F we normally use as the general function with an input of x.
Yeah, because like t
Yeah, or the term.
What was it called? Reclusive and explicit.
Now sometimes we use like f of t, so be careful. Like normally we lowercase input. A lot of times we not always, but a lot of times we'll uppercase name things and lowercase input.
Will we ever be using geometric and arithmetic?
Oh yeah, arithmetic. If you want to pronounce it
We will
right.
be using that this year.
So wait, we have this written down on our paper. We know this. I'll write this point somewhere too. You could make a little like part of your paper that says not pointless if you want. So we know the x-intercepts are when y equals 0. And we know, everything's better with sound effects. We know that a trinomial is really some x binomial and another x binomial, which are being multiplied to equal that 0. Now, what else do we know about this specific situation here?
One of the x's has to be 0.
Wait,
One of the pieces has to be
Wait, are you
0.
sure?
Yeah, because
Yeah.
one of the x's has to be 0.
Not the x, the piece, one of the parentheses things.
One of the binomials would have to be 0, but what else do we know about the binomials as we go to start to try and build these?
They both have x, and we know that one x
X
is
and
over
the
there.
constant.
2x.
One of the x's is 2x and one of the x's is alone. Right now, if we go back to the method that we've been used to,
Oh.
I like that one.
Oh, yeah.
remember, CAX goes here, so negative 24x squared. Your constant goes down here. Or sorry, your b goes down
Should
here.
we write all this down?
Unless you can jump straight to your binomials, yeah, because this is our process.
Not really. Wait, when will you know how to jump to binomial? How do you jump to binomial?
After this lesson, hopefully.
You know those math people just instantly know what they're doing.
So this should be our 2x squared, our negative 12. So you said 8 and negative 3.
8x and negative 3x.
Negative 3.
Yeah, because
8
Oh, yeah.
minus 3 equals.
yeah.
Are we all cool on how she got this?
Yes.
Here, this process is still like new for me because we didn't have this back in high school. So please make sure that it like feels comfortable for you. Once it falls, because like this is way more efficient because now we know that we're gonna 8 and -3 somewhere. I mean, there's only 2 options, and if I get the first one wrong, I just try again. So if I put them like this, it doesn't really matter where you put them. It'll just change the order of your terms. So the 2 should
I
probably go
didn't do
this
it.
way.
Yeah.
So then that would make this,
That's 4, and I
which makes this,
Easy.
which makes sense because that, yeah. So
Wow.
our 2x should have -3 with it, and our x should have +4 with it. Now be careful though, we then, algebraically, I'm going to write this out even if we remember it. This is what we're saying, is one of those has to be 0. Right? To produce a 0, to multiply and make a 0, one of them has to be 0. So to solve our green function here, we add 3 to both sides. I'm going to break my own rules and not write the steps because it's simple algebra. And then divide by 2, so x is 2 halves, or
1.5.
what? Oh, sorry. I thought you were solving this one,
No.
and I got real scared.
No.
Like I had failed you. I will just go ahead and put in my resignation.
No.
So this really gives us 2 points. Right? This really gives us 3 halves and 0 and -4 and 0. Yeah, these are our x-intercepts. So you can go back up on that same axes that you made. Go ahead and throw those on there. +3 halves, -4.
Wow, we found the y and we found the x.
Now the problem is we still only have 3 points now, right? I'm waiting for an answer. Well, yeah, because it's parabola. And that's not our vertex, right? The third point that we have is not the vertex.
Oh, but we can.
It's our
do the
y-intercept.
thing we did.
Right? This point we should have written down. That's our y-intercept. It's here. But what else can we derive?
We can get the vertex.
Ooh. Athena, what were you thinking? Don't listen to what she said. What were you thinking before that?
Like how we got the other one by looking across from it.
Or yeah, you do that. And you do this.
Talk me through the math.
Okay, so you reflect it to find the center of the 2 points.
Oh, we could, but we don't need to do that. What we want is the vertex. We know that we could reflect that point. I agree. We want the vertex.
Well, yeah. So you figure out the middle between the 2 x points, and then you plug that into our equation.
So we know we have 2/3. I agree. Like what you were saying is right. I just want to show it to make sure we're all on the same page. This distance is 4 2/3, right? So divide that. Go 2 1/3. So well, 2 back takes me to -2, -1 2/3, right? Because if I go -4 plus 2 1/3,
Oh.
because this cuts in half, that gives me 2 1/3.
And then
If we shift back this way, 2 1/3, -1 2/3. But that only gives us the x.
Wait, no, it's 3 halves, not 2/3.
What?
3 halves.
Dang it! Sorry, that's wrong. That's wrong.
I saw it.
Oh, and we can work in decimals too.
That's why I said 1.5.
Yeah, I know. You're better than me, whatever. So really this is 5 1/2, right? Because I am terrible and can't do math.
You can do math.
That's what you think.
Right
So really 11 halves. I don't know if that's any more useful. How far do we have to go in? 2 and 3/4, right? If we cut this in half, 2 and 3/4. So 2 in takes us to -2, but then another 3/4 takes us to -1 1/4, or -1.25.
Yes.
What do we do with that x value?
We know that that's the line of the vertex. That's the x value of the vertex.
Plug it in.
Plug it in, plug it in. If it's not a commercial anymore, y'all think I'm just crazy.
No,
So, we want the y value for 2x squared plus 5x minus 12.
I still think you're crazy either way. Just wait.
Oh.
Oh, that's fine. As long as it's not just my use of an irrelevant commercial anymore. Because that would just be sad. You gotta think I'm crazy, at least for multiple reasons. Careful with your calculator. I want you guys to do this real quick to see if we get the same answers. Because careful with your calculations. Always check settings. Athena came to me saying, yeah, I don't know what happened. Well, I do know what happened. I got these all wrong. Because she was in the wrong setting. She did everything else right.
That was like half of my test, and then I realized something wasn't right.
I was like, this is not a good.
You know what should be a really good prank for math people? Change your calculator to radians.
That is not a good prank because when they reset your calculator for the ACT or the SAT, it defaults to radians.
Oh, that's bad.
Yes, when you like reset to default your calculator, because a lot of geometry work we do does work in radians once you get beyond this year, and actually in this year we'll be working in radians. But please be aware, you should always check your calculators. Because if anyone has reset it, it's probably in radians, and unless one of you or a higher math person has used it, they won't know it's in radians. They won't care. It won't impact them. It impacts you. Yes, it does.
So we actually have to use radians.
We'll be using radians this year, yeah.
Whoa, what did you do?
Careful with squaring the negative.
I'm not using my calculator because I want to reset it. Or else I'll lose all my
Oh. What have I done?
Negative 1.25 squared is not a negative. Your calculator is stupid.
What?
Yeah.
Do not let your calculator make that negative.
What did you do? No one knows. Did I do something wrong?
Did you get like negative 60 or something?
No.
All right, so on my calculator,
What did you do? I must have done something.
I got negative. I think he did it wrong because I got negative 15.125.
Oh, thank goodness.
no, don't open another smart.
Oh, I thought you were saying no.
No.
Oh, wait, I did the wrong
What'd you get?
Negative 15.125.
What'd it do?
I don't know. I figured out your issue.
I didn't.
So.
Here's what I typed into my calculator.
It was 4, and then you got the this thing.
Yeah.
We figured out.
Yeah, I got 15 points.
So, ladies and gentlemen, again,
Look, X is.
if you put a negative in your calculator and square it, your calculator's stupid, it will give you a negative answer. That is not right. So, I square my value like it's a positive, then I multiply by 2, and then that, because that was really my ax squared, right, 2x squared, that 3.125 pulls down to this answer, and then I did minus because I knew that this multiplication would come out negative, and it was just easier for me to think it through that way, and then the minus 12 our constant. You should have negative 15.125. That gives us our vertex point, and then we know 5 points now. Because the y-intercept can reflect, right? And that's easier than computing the vertex, which is why we're going to work through the vertex together. We know that both x-intercepts We know both the y-intercept and its reflected point, and we now know the vertex. Right? 5 points is safe for making a parabola. If you have 5 points involving the x-intercepts, the vertex, and 2 other points, not on the same side, right? Don't do 4 and 1. But then you could reflect the other. I mean, if you did that, you could then reflect them and have like 7 points.
I'm just making sure the parabola vertex should be on the left side of
Yes,
the
at -1 and a fourth,
Okay, great. I'm ready.
-15 and an eighth.
Cool. Okay, I did it right.
0.125 is an eighth.
I love parabola.
See, you can't even stop it from coming out. Any questions on what we just did?
I think I get it. The real test is if I remember it tomorrow.
Same.
Yeah, you know, like you have to remember.
So all of this is just us reiterating, not really relearning, the zero product property. Zero product property says factor, find the zeros, that tells you 2 of your points, and work it from there. So we just did this, right? Let's try this real quick. It's a bit easier. It's just x squared plus 4x minus 5. Please, on your own,
Are we gonna do everything we just did?
everything we just did for this.
all
one.
by yourself.
All by myself.
Oh no.
My falsetto leaves a little something to be desired. Where do you even start?
I know where to
I would
start.
probably do the rectangle and or the diamond.
Yes.
Yeah. You started trying there.
No, I didn't.
Snow you didn't?
I said. Okay, y'all need to just stop with the puns.
Why? They're funny.
No, they're not.
Hey.
It's not as funny if you steal someone's fun.
Yeah,
Exactly.
but it's funny if you just make it so repetitive it's not even funny anymore.
If it's not even funny anymore, how is it funny?
Because it's like, that's what's like, because it's stupid.
Oh, this one's not bad.
No, it's simple.
Well, thank you for giving it to us.
Well, I haven't done anything.
What?
What 2 numbers add to positive 4 multiplied to negative 5?
5 and -1.
5 and negative 1, right? So x here, x there. If I put a 5 there, I might as well put a negative 1 there.
Oh wait, that's not right. I put in my B value instead of my C value, and I was like, ooh,
Now be careful, do not fall into the trap of thinking that means your zeros are 5 and negative 1.
There.
They're the opposite.
-5
Negative
and positive 1.
Negative 5 and positive 1. So this tells me the 2 points, negative 5, 0.
I thought you said we were doing it by yourself.
Well, okay. I just realized what time it is and I want to make sure we get out of here.
Wait, why does it switch?
Do the rest of it, because if I set them equal to 0, remember the algebra, if I do x plus 5 equals 0, and I solve it algebraically, it's negative 5.
Why intercept is negative?
Hey, so to review this rule again, and we'll review it many times over, your x value, the 0, is the opposite of the number in the binomial divided by the coefficient, which when the coefficient's 1, it doesn't do anything. Opposite divided by the coefficient. Coefficient's 1, doesn't do anything. Find your y-intercept, find your vertex, and reflect your y-intercept. What's the y-intercept here?
Is
Wait. What'd you just say?
What? This one was easier than I thought. This one.
This skill.
No, it's not.
Okay.
What should be the x value of your vertex?
Yellow.
It's negative
2. And so the y is supposed to be negative 5.
-2 squared is 4.
Not
Minus 8
Minus
minus 5.
which is
negative.
I was right. I did my purpose.
So then, where is the reflection of your y-intercept?
It is negative 4.
We now have 5 points.
Oh, would you look at that?
Would you look at that?
I don't know. I was worried because my answer felt really low, and I accepted the calculator.
The y-intercept is 0, negative.
And then I realized that I put negative 2 squared as 2.
Right, okay, to get the y-intercept, you reflect it over the
Okay, the line of symmetry.
the line of symmetry. I feel so special.
Are we done with this?
Alright, so is this feeling a bit more comfortable?
Yes.
You want me to rip that rug out from under you again?
No.
No, wait.
Yes, please.
No.
Where we're heading to next.
Oh no. Did you just?
Where we are heading to next while you pack up.
I don't even want to know.
Yeah, you
Don't ruin this moment.
Why can't we have one class where I leave and I know what I'm doing?
do. Oh, you do know what you're doing right now. I'm just showing you where we're going. So where we're going is that there is a parabola, right? Wherever it is. And if we envision that that parabola is actually the lens of a headlight,
Yeah.
right? Because like headlights, flashlights, all things that use a bulb in a thing that reflects, use parabolas because they have the bulb and it's got a little filament. It looks kind of like pie, apparently. And when it shines light out, it needs to bounce and head forward. Whether it shines the light down to bounce and head forward, or shines the light up and needs to bounce and head forward. This single point that the light originates from is literally called the focus. When somebody tells you to focus a bulb or focus a lens, so that's the focus point. Now, and you don't need, I'm just talking to Phil the last couple minutes before hold on, I'm still talking.
I can stand
You're
up.
fine, Sophia. Once we start talking about the focus, we will be able to determine the distance between the vertex and the focus.
So like whenever a teacher tells me to focus, I'll be like, which direction?
That, when brought to the other side, well, not even necessarily to the other side, it depends on where the focus is, will create a line that is called
Direct focus?
the directrix.
Never mind.
So,
It's so weird.
I like introing these things so it can simmer, and when we come back to it, you're like, oh yeah, you talked about it that one day, I didn't learn anything. So, this is me talking about it and not expecting you to learn anything, but where we're headed. Literally, so hold on, just think about this for a second. There are fields full of solar panels, right? Flat solar panels are only so efficient because the sun is coming one direction. It probably hits better at a certain point than it does another. It's just flat, right? So they're now creating solar panel fields that using a lot less technology, like a lot less of the actual solar receptors. Imagine this. You're looking down a field that is a giant metal parabola, right? So it's just, hold on, it's just reflecting, right? When the light comes in from up here, hold on, no, it's even cooler than that. There's one solar receiver at the focus point. all of the light that comes in bounces up into that focus point, whether it hits out here and bounces, hits down here, and so using much less solar technology, they can harness all of that sunlight.
That's cool.
That is cool,
You know what?
and that's where we're headed.
Math teaching you about energy conservation.
I can't wait.
All right, have a great day,
I
guys.
share